Okay, I'm sure it's recording. Okay. So, guys, we've been talking about transformations, right? But only for parabolas. We're going to talk about transformations now for all types of equations. So, the key term we need to talk about is a parent graph. The parent graph is the most basic form of a particular function. And speaking of Star Wars, I have a very cool slide I'm going to show you guys. Let's see here. Back to school. There we go. Back to school. Night, Algebra 2. Okay, I just read parents on back to school night about a month ago. By the way, that was me in a Chewbacca costume last year. My son wants me to wear it again. Like, I don't know if I want to wear it. I got really hot in it, especially if it's gonna be hot in October. But anyway, Star Wars, right? You guys know who these people are, right? There's Darth Vader, the Emperor, Chewbacca, Obi-Wan Kenobi, Princess Leia, but whatnot. Why did I show this to your parents? I showed this to your parents because this class you're gonna learn about different kind of functions, right? Like, for example, let me clear the screen for a moment. In this class, what are we gonna talk about? Like, we talked about right? Product function right now. What we haven't really talked about yet are like absolute value, cubic, square roots. We have done exponential actually. One over x we did talk about the other day. Trig will do the second semester. Logs will do the second semester. But in order to make sense of math, especially later on, like when you move on to pre-calculus next year, you move on to calculus in 2 years from now. In order to make sense of all this stuff, you really have to have intimate knowledge about each of these functions, and also how they're related with each other as well. Like, how do we, how are these two related? Like, there's actually a relation between these two. The exponential log, but the sine and cosine relation between these two, right? These are somewhat interconnected. So we have to understand why they increase, why they decrease, why there's a high point, why there's a low point, why does that sine curve have waves, right? Just like the movie Star Wars, right? Like, if you were to watch Star Wars, let's say like you've never watched Star Wars. Like, my wife doesn't know Star Wars. She didn't grow up. She grew up with like Sound of Music. I didn't watch Sound of Music. I don't know. I'm just more of a typical guy. I grew up with Star Wars, right? Child of the '80s. But like, if she were to watch Return of the Jedi, she'd have no idea what's this guy's doing Return of the Jedi and why he's asking her for money, and how he got involved in training him, and how these two are interconnected, and how these are interconnected. They're actually twins, right? And that's his father and whatnot. So I had to stop and pause the movie several times with my wife when she was watching Star Wars: A New Hope, because she didn't understand. Just same with math, right? Like, if you don't really know these, it's gonna be hard to go further in math if you don't have intimate knowledge about. So that's why we're spending all this time on parent functions, because you have to have intimate knowledge about these functions if you're going to do calculus with them 2 years from now, or you're going to do pre-calculus with them next year. You have to really have a deep understanding of these functions. So just like the movie Star Wars, which is 9 episodes, and like they're so interconnected, and there's even more characters than these guys, right? So that's kind of just the analogy I share with your parents on back to school night, and they seem to like it. Don't know if it's too corny for you guys, but anyway. So what we're going to do is we're going to transform all these different types of functions. So the parent graph is the most basic form of a particular function, and we're going to talk about the parent graphs, and then we're going to shift them afterwards. So what we've done so far is this. We've done y equals x squared, right? We've done that. That's a problem. But here are the other ones we're going to talk about. We're going to talk about, and I'm going to write it like this, by the way. F of x, f of x, f of x. So we're going to use f of x notation. Y and f of x are the same thing, just so you know. I want you to get used to the notation, because that's just what we do in math. So f of x is the same thing as saying y. And the different functions we're going to look at are going to be x cubed, root x, 2 to the x power, absolute of x, and 1 over x, just like you saw in that schematic I showed you about a minute ago. So we're going to look at all these different types of functions. If I want to label what they are, like their names, this is called cubic, because there's a cube. This is called square root, because you're square rooting, obviously. This is an exponential, which we have done. This is absolute value. I know you guys seen that before. And that's called the reciprocal function. Okay. So graph the parent graph on the center of a large graph paper. Nah, we won't do that. What I'll do is I'll generate these graphs for you guys. You can put them in your notes. And then we're going to talk about the domain range for each of these. Okay. Any questions so far? No? Okay. You got all copied down? Good? Okay, cool. All right. So let me delete some things here really quickly. Give me 1 sec. Just going to move the screen just a tad. All right, here we go. Let me move my screen. We'll position it like this. Okay, great. And let me just move this back up. Here we go. Cool. All right. So it says graph the parent graph on the center of a large graph paper, blah, blah, blah. What is the domain range of the parent function? Describe in words transformation. Draw the transform graph on the same grid, blah, 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 and so forth. Okay. So what I'm going to do, I'm going to make 5 different axes here. Kind of blow each one, right? And do a quick sketch. So cubic will look like this. Square root looks like this. 2 to the x looks like this. Absolute of x is a V shape. And 1 over x, we did talk about the other day, looks like this. Okay, those are the 5 from up above. Now we'll do domain range for each of these. D and R. And I'm going to make it like a table just so it's easy to kind of write all this out. Oh, thank you. Here we go. Oh, right there first. Okay, so I'm going to have you guys help me out here. I know you guys can do this. What would you say the domain would be for the first one, for x cubed? Do you see any reason there'd be a restriction? I mean, all real numbers, exactly. How do you guys like to write? Do you guys write as ARN, or do you guys do something else, or
Double staff bond.
double staff? I like that. That works. Or you can say ARN. That's fine. Yeah. Actually, I'm kind of struggling. Let me get my stylus out. Hold on. I'm kind of struggling doing my maths here. So, so Pierce, you're saying like this, right? Yeah, that works with the R right, with the line right through the middle. Oh goodness. Let's try this one more time. There we go. Steady hands. Or ARN. Okay. What about the range? If you look, range is the Y values. So you look at the graph, it goes up forever and goes down forever. And in the middle, looks like everything's covered, right? So everything for Y should be covered, right? So same thing. The range is all real numbers. Well, let me write this about a little more neatly. So domain and range. And again, that's going to be all real numbers or ARN. Okay, let's look at square root. Can you square root negative numbers? No, 2 real numbers never multiply to a negative. Like -2 times -2 is +4, right? Forget about it. And plus, look at the graph. It starts at 0. Hunter, go ahead. You have a question? Yeah, it's just x is greater than or equal to 0. And what about the range? What's the lowest y value here? It goes up, right? So you have y is greater than or equal to 0. Okay, let's take a look at 2 to the. After we've done this already, what's the domain for exponential functions? All real again, or you can say ARN, up to whatever you want to write. And what would be the range for this one? Y greater than 0. But not equal to, right? Because you can't make 2 to the x 0. We talked about this, right? You can't multiply 2 over and over again because it's just impossible. It's very close to 0, but not exactly 0. So that would be y is greater than 0. Absolute value. We haven't talked about absolute value, but it's pretty easy when you look at it. Absolute value just makes things positive, right? If you have a negative number, it's positive. It's positive, stays positive. Same thing again. All real numbers for domain or ARN. And this is going to be y is greater than or equal to 0. And then lastly, this was all real except 0 and all real except 0. Because for whatever x, you can't put in 0 for x, right? And also y equals cannot be 0. The top is 1. For y to be 0, you need the top. These are the top is stuck at 1. The x can get really big. It's really close to it, not exactly. Okay. Now, describe in words what happens when we compress all this, or when we do all these changes. So here's what's happening in general terms. So this will be describe generally what happens. And we're going to put this in, I'm not sure why there's, oh, actually, I'm a little confused why it's written this way. Give me 1 sec. Oh, I got it. So it's going to look like this. It's going to be like 2 times f x minus 3 plus 4. There we go. It's a little confused at first. Okay. So that's what goes in the boxes. First box is an x, second box is an x. So what this means is you're multiplying the function by 2, subtracting x by 3, and adding 4 to the outside. So that's what's happening again. You're you multiply the function by 2, subtract x by 3, add 4 to the outside. Okay, does that make sense? Right, because you're multiplying by 2, right? Subtracting x by 3, add 4. All makes sense, right? But let's talk about what it does to the graph. That's what I care about. And I did it generally because we're going to apply this to each of these 5 parent graphs, right? We're going to apply it to each of these 5. So let's take a step back and think about it. If you add 4 to the function, just we saw in previous classes, right? Like, for example, I know people in the video can't watch this, but let's just y equals x cubed, right? What if y equals x cubed plus 4? What if I just added 4 to this function? What happens to the graph if I add 4 to this function? Where's it going to go? Up by how much? 4, yeah, of course, right? What if I did this here? Y equals root x plus 4. So right now, where's that endpoint? It's at 0, 0, right? If I add 4, where's it now? 0, 4. Right, totally. Here, remember we talked about asymptotes? There's an asymptote at y equals 0. So if I did y equals 2 to the x and plus 4, what happens to this graph? It goes up 4. Same thing with the other ones here. If I did y equals absolute of x plus 4, it goes up 4. If y equals whatever x plus 4, it goes up 4. So now it looks like this. And the asymptote is at y equals 4. So that's all this ever does. The plus 4 causes it to go up 4. That's all. That's easy. Yeah, go ahead.
So we're at x minus 3.
Yes. Move it to the right, actually. We'll talk about that in a second.
Yeah, why does it?
I'll explain. So here's what you're going to say. I'll put in green. So describe transformations. We go up 4. Okay. We go up 4. Now let's talk about the 2. I'll talk about minus 3 last. Let's talk about the 2. Markers again. Okay. The 2. What if I did y equals 2 times x cubed? Okay, so what's going to happen to this graph if I multiply that by 2? What do you think? 100? What do you mean by compress? So does it get skinnier or fat? It's get skinnier. So actually we say vertically stretch. We say vertically stretch, right? Ellie, go ahead. Oh, yeah, but or you're just going to answer the question. Sorry, you're not raising your hand.
No, sorry. She was.
Oh, you're all good. It's all good. So it stretches, right? Same thing here. If I do y equals 2 root x, all the y values get multiplied by 2. If you have like 1 comma 1 right here, right? Now if you put 2 root x, now it's 1 comma 2. It gets stretched, right? Same thing here. If you put a 2 out in front, it gets stretched. Put 2 out in front, these actually get steeper, right? Instead of putting 1 comma 1, now if you have y equals 2 outside of x, what's it going to be now? It's going to be like that, right? It gets stretched. Likewise here. So what the 2 does, it's going to vertically stretch the graph. Okay. So it gets vertically stretched. By a factor of 2. And lastly, there's one more thing that's happened. This is the part that's confusing. I say it's confusing for last. The x minus 3. That impacts x, right? The x value is dropped by 3. In order to counteract that change, if you're subtracting 3 from x, how's the graph going to do to counteract, Jack? It's going to go 3 to the right. Yes, good, exactly. It's going to 3 to the right. So I think y equals, so I don't know, answer your question as you're asking why that happens. So here's the deal. Right now, I'm 0.00, right? Yeah. If I plug in 3 here, what's y can equal? 3 minus 3, of course, is 0. 0 cubed is 0. So now the graph looks like this. So it's counterintuitive, but it actually goes right. Same thing here. If y equals root x minus 3, I can't plug in 0, obviously, right? It would be negative. I can't even plug in negative numbers. It's still negative. But if I plug in 3, so that's why it goes 3 right. It's counteracting that change. It doesn't happen with the other ones because those are more intuitive. Like obviously you're adding 4 to y values, but if you do directly to x, it actually does the opposite. So in this case, and I can show you the other ones too, but you get the point. So it's going to go right 3. So that's what happens. Okay, drawing the transform graphs. I'll do it for one of them because I think it's a lot to write. So let me position it like this again. Okay, so again, what did we do again? We did up 4. I'm just going to repeat what I had earlier. Vertically stretch by a factor of 2 and went right 3. Okay. Now I was asked you to draw the transform graph from your parent graph. What's the domain range? Let's do it for y equals outside of x. I'm not going to do it for all 5. I'll have you do the other ones in groups. I'm actually going to give each of you guys different ones to do. But I'll do it for y equals outside of x. So the other 4 we'll do in table groups. Okay. So y equals outside of x. That's easy, right? Looks like this. Make a little table. Right? Pretty easy, right? We're good. Ooh, that. Gosh darn it. Cool. All right. Now, let's do this in dark blue. 2 absolute x minus 3 plus 4. So what are you supposed to do? You're supposed to take this graph and make some changes. That's what I call the transformation. I was going to transform, it's a change, right? how am I going to change this graph? Clearly, I'm going to move it to the right. Clearly, I'm going to move it forward up. And clearly, I'm going to stretch it. However, this is very important. And I will be very harsh when I grade this. When it says describe the in words of transformations, oh, that's a new one. Sorry, that's a new one. You're gonna do this first. Okay. When you do transformations, I can't say what I help some of that stuff, so don't review. Still, if I get it, but I'm going to be with you guys every day for next 7 months. You have to state the transformation in the proper word. I'll remind you on the test. State the transformation properly. So you got to state the horizontal shift first. You got to say the vertical stretch second. You got to say the vertical shift last. Why? Why does the word matter? And when I think back to what you guys did like back in middle school, you had to combine numbers, or maybe you guys. I know you guys not Facebook, you guys middle school, but sometimes on social media you see like people like, what did, here's an expression, what does it equal, and have like people in their 50s, 60s. That's what that's what happens. They don't know that, but anyway. When you combine numbers, what rule do we have to use? Starts with P. PEMDAS, thank you. That's the reason why it's PEMDAS. Yeah, a lot of people forget PEMDAS in their 50s and 60s. So PEMDAS, because think about it. That's like parentheses. That's got to be first. What comes after the P, the E? I don't have an exponent, so don't worry about it. What comes after the E, the M? Is 2 being multiplied? You bet. What comes after the M? D, and have no division, don't worry about it. What comes after the A, no addition? Yes. So the P, the N, the A have a parentheses, right? Because inside the bracket, the absolute value, have multiplication, have that. So very, very important. You have to state it in the right order. Very important. So actually, I kind of messed that one up. I should have actually said right 3 first, then vertical stretch, then up 4. So now, when I draw the transform graph, it's going to look like this. I'll do a new coordinate plane because it's getting a little busy. I'll do it down here. Okay, so my new table. So I have to multiply each of these by 2. So I got to multiply these by 2, then add 4. Multiply by 2, add 4. Multiply by 2, add 4. And then here, I'm going to add 3. 3 plus, 3 plus, 3 plus. You're adding 3 to x because you're going right 3, right? So that's plus 3 to x, plus 4 to y, and times 2 for y, or 2y. Actually, let me rephrase that. Times 2, then plus 4 to y. Okay. So the new table is going to look like this: 3, 4, and 2, 4, 6, and 6. 1, 2, 3, 1, 2, 3, 4, 4, 6, 2, 6. That's a new graph. Because I want to rewrite 4 up stretch, right? But when you impact the table, you have to keep track of all the changes made in the right order. So you got to multiply, then add, but add of course is adding. So that's how you can make the new graph without having to actually think too hard about it. You just really just look at the parent graph, look at the parent table, make an adjustment. Make an adjustment. So in essence, here's what we did. to graph the transformed. Oh my goodness, what is going on? Why is it so big? Whoa, how do I update this? Hold on, let me delete that. Okay, hold on a sec, this is driving me nuts. That is insane. Your text. I have no idea why this is so big. I will need to figure this out later because I'm. Oh, duh. No wonder. Hold on. Okay. Too small. Lovely. Here we go. Let's go 36. To graph the transformed function, adjust the table for the parent function and remember, generally speaking, a times f x minus h plus k. Okay, that's in essence what you got. What we're doing every single time for any parent graph. Okay, so to graph the transform function, adjust the table for the parent function by applying the h and p values properly. Here's the table for the parent graph. That was easy, right? Duh. Outside of x. I know this is true. Here are the a, h, and k values. A is 2, K is 4, H is 3. Applying correctly, add 3 to the x size. Multiply y by 2 to add 4 is a PEMDAS. Once you have a new table, make a graph, you're done. Okay, go ahead.
What is that?
No, it's just a notation. It's like y. If you want to replace it, actually, if you wanted to, but the only thing is that just do the right function notation so you can show that x is a function of x, and that you're just adjusting it. So f of x as a whole is y. This is what this function itself. Yeah, it's not a letter. I'm actually glad you brought that up. It's not. It's just a notation thing. Okay, let's try this one more time, and then I'm gonna have you guys do a unique function on in your table groups. Okay. So number 5. Here we go. So let's do this. Let's do negative f of x plus 5. So you're doing negative f of x plus 5. So let's figure out a, h, and k are. Remember, generally speaking, it looks like this, right? And what's our function? We're working with absolute value of x, right? That's what we're working with right now, absolute value of x. What's the a value here? If you have a negative on the outside, what are you multiplying up by? -1. Now, h, careful here. You have x plus 5, but what's in h's place, though? Is it 5 or -5? Yeah, it's always the opposite. And are you adding anything to the outside? Nope, so you put 0. Okay. So describe what's happening. So describe what happens, you'll say this. You're going to reflect. Actually, let's go in the right order. You're going left 5. Then reflect about the x-axis. Now, you could have said the other way and it would have been okay. But once you get in the habit of putting in the right order, if you did reflect first and then shifted left 5, you still get the same graph. But again, once you get in the habit of putting in the right order. So that's what's happening. Left 5, then reflect about x-axis. So now let's actually draw it. So the parent function looks like this again. We know this, right? And little table 0, 0, 1, 1. Ah, geez. 1, 1, 1, negative 1, 1. Right, we know this. Okay. Now, the transformed graph. the transform graph is going to look like this. We'll do it in dark blue. Y equals negative absolute of x plus 5. Okay. So if a is negative 1, you multiply that to y. Okay, so a always multiply to y. I'll actually write over here. H, you add or subtract to x. And k, you add or subtract to y. That's actually pretty important because I don't know if I emphasize that enough. That's exactly what those things do. Of course, there's no k, so don't worry about it. H, you're doing negative 5. So you're doing negative 5 plus 0. Negative 5 plus 1. Negative 5 plus negative 1. So you're taking away 5, right? So the new table is going to look like this. Negative 5 comma 0. Negative 4 comma negative 1. And negative 6 comma negative 1. So you have a point right here, a point right here, point right here, and looks like that. Because we shifted 5 left and flipped. That's the transform graph. Once you get I know it's a new way of graphing, but you need to get a habit of doing this because we're going to apply this universal technique for every function. And you move on the pre-calculus, the same thing. Your teacher's going to do the same exact thing. They're going to expect that of you guys. So I know that was a little long. Questions? We're okay? Okay, now it's practice. So here's what we're going to do. On the next page, you're going to do a parent graph, and then you're going to transform it. So here's what we'll do different functions for each group. So I'll just put like the initials of each group. So that table, you have 1 over x. This table, Pierce, Jack. You guys are going to do y equals square root x. And in the back, what was the other one we had? Oh, cube. Yeah. We'll do y equals x cubed. Lastly, it'll be called cubic. You guys will do 2 to the x. Come on. So you're going to write the equation I gave you, make a table, draw it, and then the transformation is going to be this. It's going to be true for everybody. You can do 2 times f of x minus 3 plus 4. Everyone's going to do the same transformation. You're going to shift 3 right, shift 4 up, and multiply y by 2. And you're going to give domain range, give anything that's interesting, describe where the locator point, the vertex, has moved to. Once we finish that, then we are done for today. So it should take about 5 to 10 minutes. I don't know. So again, 1 over x, y equals root x, y equals x cubed, y equals 2 to the x. That's what you guys are working on. I'll come around and make sure you guys got it. And then we're good for today. And then you can don't do the homework quiz. So we'll do the homework quiz. What do we have? Yeah. Darn it. Yeah, it's my fault. I took too long. So I'll move it. Good job. Yeah. So do tables. Do that first. So guys, start with the parent function. Don't do the transformation yet. You get the parent function straight first. Okay. So you guys have 2 2x, right? So if you want to just that table, square root function. You guys can square, so plug in. So you guys can't do negative numbers, obviously. So you get start with 0 and board. Okay, so obviously you guys can't plug in 0, so don't worry about that. So you're just plugging in. You want how to go to the table? Yeah, totally. Oh, that's not much. It's second. Oh, sorry. If you guys like, you can use your graphing calculator to do this more efficiently. So for example, the group that has like y equals x cubed. So you can punch in your calculator, and if you did second table, you get all your values like this right here. So you can totally plug into a table and get the answers really easily. And then you're going to do the transformation once you have the parent graph figured out. So and let me update Schoology. We won't do the homework quiz head, move it to tomorrow. What's fun? Hold on, I'll be in a sec. Okay. Hold on, let me go back to the notes. Okay. Yeah, go ahead. Oh, yeah. Get the table set up. So you can't do it and so, remember we started. Yeah, that's all. Okay, let me know when you have your parent function. Okay, good. Then you transformed it. Great. And then that looks good to me. Yeah, we got it done. Great. Okay, so your parent function looks good. Great. So we transform it. We're going to do what we have up there. Of course,
So yeah, so now what we're gonna do is we have to go through like. For us. It's on purpose, right? So yes, so what we did is add here. Here, you know, what's new, and then. Yeah. That's kind of. Well, you could, but let's. Yeah, so now we have to make what I said. So this obviously comes for this is what we start to
Just so hard. What is that? It's more value.
We should. Here. Multiply by two. We wouldn't have to. They multiply by two. 4 times 44. And $1. What's 4 times?
Are you kidding me? That's 5 6. Four times. What is it? 10 cents now? 12 cents. 6 cents. 10 cents. I'll make another trade. You're gonna
be adding for it. That's 4.
4 diamonds. Look down penny from the.
Then for 12 plus 1 for 2. For 10 and a half. Wait, that's $4.
3 parts.
You know, this weird way of putting it.
3 parts.
Because X minus 3 can be X 4. You're not really plugging that one. That's the part. I mean, I guess you could do that. Yeah, so that's probably. I wanted to dive into that phase. And just.
My phone. Deal. My phone for Four spades. 4 times.
I don't know.
Yeah, so. So you had to add 3 to these shapes, right? Don't add 3, so she went 1, 2, 3, 4. And then what you want to do is multiply by 2 and have 4. Which looks like yours. Yeah. Yeah, so then. The group, yeah, right, so that's an asymptote. The asymptote is also. That's not what you want to and then plus 1, 3, 2, 2. Wait 1 sec. Oh yeah, there's also the 4th asymptote, which is goes out. So you want to do that, that's why.
I really do.
You want that.
More.
Yeah. You want to add 3 things.
I'll give you.
You want to multiply it by 2.
Wait, okay.
Yeah, so you multiply it by 2, add 4.
Oh, it's still there.
So that's.
I put the mark on the wall. You're so stupid, bro.
Yeah.
The mark is still there.
Whoa.
Let me see it. Let me see it.
In my.
And then
Household is right next. No, I'm gone.
All right, good work, guys. Glad we did this.
The other one's still there. This is still there. Yeah. If that one's still there, then